Search a document collection for the word connect, and you probably also want everything that says connected or connecting. To a computer, though, those are three completely different strings. Stemming is the classic trick that closes that gap. It reduces words to a shared root so that different forms of the same word get treated as one token. Today, we're going to look at how it works, where it shines, and where it goes wrong. Let's start with the problem it solves. Treating every word form as its own separate thing bloats your vocabulary and quietly costs you matches. Connect, connected, and connecting become three unrelated features. So a search for one misses the others, and your model wastes effort learning that they're basically the same word. Multiply that across a whole language, and the waste really adds up. Stemming collapses all those forms down to a shared root. Running, runs, and runner reduce toward run. And now a single stem stands in for the whole family. Your vocabulary shrinks, and a query quietly matches every inflected form of the word at once, which is a huge win for search and for any model working with text. So how does a stemmer actually turn a word into its root? Follow one word through the steps. First, you take a single word straight from the text, something like connecting. No dictionary lookup and no grammar analysis yet. The stemmer is about to work purely on the letters in front of it, which is exactly what makes it so quick and so simple to run at scale. Next, it strips common prefixes and suffixes using a fixed set of rules. The most famous stemmer, the Porter stemmer, is really just a long series of these suffix stripping steps applied in order. Off comes the ing, and off come other familiar endings, one rule at a time until nothing else applies. Then you arrive at a shared stem, in this case connect. Notice the stem doesn't have to be a real dictionary word. Studies, for example, chops down to studi, which isn't English at all. That's completely fine because the stem is just a consistent label, not something a person ever needs to read. Finally, every other form of that word maps to the same stem. Connected and connection land on connect too, so all of them collapse into one token. That shared token is exactly what search and text analysis were after, because now the machine treats a whole family of words as one thing. Now let's pin down to three things that define stemming. Above all, stemming chops words down to a root using rules. It's crude and heuristic, just cutting strings, which makes it wonderfully fast, but also a little blind. It can overstem, merging words that shouldn't merge, like universal and university, or understem and misforms it really should have joined. That bluntness is the price you pay for the speed. Because of that chopping, different forms of a word share one token. Your vocabulary gets smaller and your matches get broader all at once. That single benefit is why stemming has quietly sat inside search engines and classic text pipelines for decades, doing its work all over the place without much fanfare. And then there's its careful cousin, lemmatization. Rather than blindly cutting, lemmatization uses vocabulary and grammar to return a proper dictionary word, the lemma. It's more accurate but slower, so you're trading speed against precision depending on what your task needs. For a fast search index, crude stemming often wins anyway. Okay, let's pull the essentials together before we finish. There are four things worth remembering here. Stemming reduces words to a root by chopping off prefixes and suffixes, so inflected forms share a single token. The famous Porter stemmer applies rule-based suffix stripping, and the resulting stem need not be a real dictionary word. Because it just cuts strings, it can overstem or understem. Its careful cousin, lemmatization, is more accurate but slower. Fast, simple, and language-friendly, stemming stays popular in search and classic NLP. Want more of these ideas made simple? You'll find them waiting at Standarity.com.